Gentlemen, good morning to all of you. Can you hear me?
Yes, sir. Can able to.
Okay. So let me start today's session. As you are aware, today's session is all about Marpol Annex 6, and let me just make it full screen so that I can start the session. So, gentlemen, this is what we are going to discuss today. I think if you just look back and then see in Marpol, out of 6 annexes, so which annex has caused a lot of amendments and changes in the last 4 or 5 years? It is always Marpol Annex 6. And as you can see in this slide, regulations for the prevention of air pollution from ships, technical and operational implications. Now, you see the funnel of a ship and black smoke is coming out. As all of us are aware that black smoke from the funnel is prohibited. But does Marpol Annex 6 address this issue, gentlemen? You can interact with me, you can talk to me. Marpol Annex 6, does it address black smoke? Students, you can tell me.
No, sir.
Yes or no?
No, sir.
Yes? Is it?
Yes, sir.
Yes, sir. It is regarding air pollution, so it
Yes, sir.
must be connected with black.
Okay, but to our surprise, you will see this particular black smoke is not addressed in Marpol Annex 6, because if you see, Annex 6 is worried about major factors like like for example, if you just look back and then look at the black smoke, what is the reason for this black smoke? But people on board the ship, can you stop this black smoke or can you make it right? Yes or no? Because this is an issue. It has got something to do with combustion of a particular engine, boiler or main engine or whatever it is, where the problem can be solved. You may tell me it is air fuel ratio is not good, or fuel pump injection is not proper, or maybe some injection timing is not good, or boiler furnace the fuel quality, or fuel is pouring, air fuel ratio, or so many things, atomization is not proper. So this type of issues can be solved by the ship staff. So your Annex 6 is worried more about problems at macro level. As of now, if you just see, when you look at air pollution, there are 3 issues addressed. The first issue is what we call acid rain issue. Acid rain, and the second one is global warming, and the third one is ozone depletion. These are the major issues addressed by Annex 6. Whereas the issues like this black smoke, yes, every administration or every country or every flag state, they have their own regulation. Like you look at regulations in US, they call it Clean Air Act or Clean Water Act. Likewise, in UK, they have a regulation. In Japan or Australia or in India, so many countries, they have their own regulations for black smoke. And of course, in US, you might have come across what they call Ringelmann's chart. So Ringelmann chart, it gives different gradations of the color of the smoke. So, but your IMO regulations, if you see Marpol Annex 8, as I have said, the focus is mainly on those issues which are very difficult to solve. For example, if you look at all these 3 issues, like ozone depletion, or your global warming issue, or acid rain issue. Now, who is responsible and how can we solve this issue? Can you put this responsibility on any one country? Or the solution, is it that simple? As you can see, collectively, every country is responsible for these issues. So that is why Annex 6 or IMO regulations look at the problems at macro level, and many guidelines are given for the flag states to follow. Of course, when you are looking at air pollution, there are a lot of, your IMO is very much confined only to ship-related pollution regulations. Otherwise, your air pollution, what is coming out from the trucks and cars, and what is coming out from power plants and thermal power plants, the black smoke coming out or carbon dioxide coming out, your IMO regulations Annex 6, as all of us are aware, it focuses mainly on ships. So today in learning objective, let's go a little more in detail, and we are just going to look at the overview of this annex. That means what are the very important regulations addressed. I'm not going to go by regulation by regulation, only the highlights where we need to just focus. And the next, the learning objective, if you look at the second point, ozone depletion potential, acid rain, global warming potential, which already I have mentioned it. And also, it follows with the IMO 2020. I think all of us, sulfur cap, all of us are, it is still fresh in our mind, So that relates to acid rain. Then energy efficiency on ships, that relates to global warming. Energy efficiency, all along we keep talking about carbon dioxide emission control. Same thing, if you look at your energy efficiency design index and your energy efficiency operator index. Apart from that, I have added one more in our learning objective, verification of compliance. As you can see, this verification of compliance has been very recently added to Marpol Annex 6. As you are aware, they have added the same thing in SOLAS. If you now look back and then ask how many chapters are there in SOLAS, it is not 12 anymore. Because very often earlier we used to keep on telling SOLAS has got 12 chapters. And the last 12th chapter happens to be additional bulk area safety. But we move on from now, as of now, SOLAS has got 14 chapters. Chapter number 13 is your verification of compliance. What you see in this slide, the last point. Verification of compliance is in SOLAS also. And the 14th chapter of SOLAS happens to be the polar code related regulations. But in Marpol, you will find almost, except Annex 3, in every annex you will see this verification of compliance. So what is this? What does it indicate? So these are the updates, we will just one by one, we will just see. As you are aware, our ship, when we are at sea, we are surrounded by so much of regulations. The regulations, in fact, the IMO, the objective of IMO itself is what? Safer shipping, safer and secured shipping, and cleaner and energy efficient ships. So that covers all. So as you can see, whatever is surrounding this particular ship, this particular slide, if you see right extreme on your right extreme, starting from ship recycling convention, which is still pending to come into force, and what we call Hong Kong convention. Then one by one, if you see ODFs, cleaning agents, garbage related, cargo residues. So, but effectively the regulations for ships can be controlled because the ship has to have so many certificates issued by the flag states, but the certificates will be issued only after a survey, only when the required IMO related regulations under whichever convention it comes, whether there is compliance, then after a survey, the certificates are given by the flag states, but that's not the end of it, because the survey, with the certificate, even though it is valid for every year, for 5 years, every year we have an annual survey, in between we have an intermediate survey, and also whenever your vessel goes to any of the ports, there will be a surprise inspection, what we call port state control. So the shipping industry, which transports about 90% of the world trade, is a well-regulated industry. So every convention is very effective. And now focusing more on Annex 6 now, this is what I have found out, I have seen in this slide I have taken from European Union website. Just see that, impacts of ships emission. So they are looking at the health issues of human beings. They are talking about, as you can see, respiratory effects, cardiovascular, and acid rain. Acid rain, they say loss of chloroplane. Acid rain is basically what it is. Your SOx and NOx, whatever is coming out, either from your diesel engine, generator, auxiliary main and boilers, your acid, that means sulfur oxides and nitrogen oxides, when the ship emits all this, it gets mixed with the atmospheric air, and eventually what happens, when it rains, they say the pH value becomes a bit acidic. as all of us are aware, that's pH value 7 is neutral, but then it is not 7 anymore. So when it rains, they have done studies on that, and it is less than 7, making it acidic. But if it is acidic, it's going to have its own issues. Then the next one is eutrophication, as you can see there. Then ozone depletion, the ozone layer, what we have all around the globe, all around our universe, at a distance of about, say, 15 to 20 nautical miles all over. And if there is a depletion, in fact, the hole in ozone layer, initially in 1987, if you just look back, in 1987, they had, under United Nations, they had a conference in Montreal. So it is called the Montreal Protocol 1987. So at that point of time, the ozone depletion was initially, the scientists or environmental engineers, scientists, they have identified this issue and discussed it in the World Forum. And after that only, we brought so many issues, how to contain this ozone depletion, and halon, putting a stop on halon or stopping the production of halon, all those things, it's all started after that. So as you can see, the impacts of emissions, from ships have all these issues. And if you overview of Marpol Annex 6, if you see, only I am just highlighting the important ones which we will discuss during this session, because this session is too short, about 50 minutes or so. So I'll just highlight, like ozone depletion, the regulation number 12, you can see. What does it say? That means you shouldn't be using any hydrochlorocarbon. Yes, you all know that is outdated now. That means, now then we moved on to hydrochlorofluorocarbon, HCFC, that happens to be your R22. Earlier we had R11, R12. Now R22 is also phased out, and then they say by 1st January 2020, that means this year, you stop hydrochlorofluorocarbon also. Anything, if you have anything chlorine or chloride related, and you are going to have issues with your ozone layer. So depletion of ozone layer we don't want, because it affects the environment. So what needs to be done now? So switch on to hydrofluorocarbon. I think in my refrigeration session, I mentioned it earlier. So it needs to be hydrofluorocarbon. Of course, the refrigerants, what we are having is R134A, 404A, 407C, 410A. So likewise, refrigerants, what we have now is blended refrigerant hydrofluorocarbon. That's what the regulation 12 talks all about it. And move on to regulation 13. Here it is nitrogen oxides. Now, if you just look back till 2012, the focus from Marpol Annex 6 is basically only on ozone depletion as well as sulfur oxides and nitrogen oxides, or you can call it ozone depletion issue and acid rain issue. Only these two issues were focused in Marpol Annex 6 till 2012. Then later what happened in 2012-13, the first time, the global warming issue was also critically looked at, and Marpol Annex 6 IMO has an MEPC in IMO, what we call Marine Environmental Protection Committee. So they have come out with the required, regulations and the requirements for the ships, and that's where we started talking about your EEDA issue, EEOI issue, then what we call SEC, we call it, and International Energy Efficiency Certificate requirement for all the ships. And this type of issues and all started, that is from 2013. And what you see in this list here, in this particular slide, these are the issues, which was there earlier. So I will spend less time here. And then global warming issue, we will spend a little more time. But still, let's now look at this nitrogen oxides. Nitrogen oxides, basically, where does it come? Do we get nitrogen oxides from boiler combustion? Gentlemen, can you tell me?
No, from combustion in engine, sir.
Yes, you are right. So nitrogen oxides is basically combustion. It's not boiler combustion, because boiler combustion, what happens? Boiler combustion, you will see the combustion temperature, combustion pressure, it's all very less. And at that temperature, in fact, when we are talking about NOx, NOx is basically nitrogen and oxygen chemically reacting, which normally doesn't occur. Now you see the atmospheric air, what we have. In atmospheric air, we have oxygen, 21%, and the balance predominantly it is nitrogen. So oxygen and nitrogen coexist. So not an issue. There is no reaction. Ambient conditions. But what happens? In the boiler is not, in the boiler combustion also it's not an issue. Then when nitrogen reacts with oxygen, that happens at an elevated temperature. Now, where does this elevated temperature, where does it occur? It occurs in the combustion chamber of your diesel engines. So that is why you will see nitrogen oxides formation is possible only in diesel engines. So I will show you a slide a little, we'll just move on. This is just concisely, I'll just discuss, then we'll go to the individual slides. Then the next one is sulfur oxides and particulate matter, and this is where we are going to talk about sulfur cap, or what we call IMO 2020. I think recently, by 1st January, we switched over all over to sulfur fuel in global areas 0.5 and emission control areas 0.1. And of course, instead of 0.5, if ship owner decides to continue with 3.5, of course, then we need to use the scrubber or whatever it is. So that we will see. And the next one is regulation 15, volatile organic compounds. And this basically is nothing but your, this regulation, you can say basically it applies to tankers. Like if you see tankers, like take an oil tanker. So during cargo loading, nowadays you will see during cargo loading, it's all close loading. That means your tanks are having inert gas, and then your completely inerted tanks with a IG pressure of about 600 to 800 millimeter water gauge. That's the pressure you maintain in the cargo tank. So when you start loading, what happens to this IG pressure when cargo level keeps coming up in the tanks, cargo tanks? So the IG pressure is going to increase from 600, it will go to 700, 800, 900. But we can't afford to just keep the pressure rising, without any control. So then what is the solution? The solution is we need to have some sort of a controlled ventilation, maintaining the pressure above the atmospheric pressure, say around 700, 800, whatever. But how do we do it? In olden days, what we used to do is, tanker people, you are aware that we have something what we call moisturizer. So through the moisturizer, we need to ventilate. But when you do that, what happens? It goes into the atmosphere. So atmosphere means what does it, your ventilation from the cargo tanks, when you ventilate, you will find a mixture of your cargo vapor and your IG. IG going out into the atmosphere is not an issue at all. Because basically, what is IG? IG is basically a bit of carbon dioxide, about 13%, and oxygen maybe about 5% or less than 8% in any case. And the balance is nitrogen. So that's not an issue. But along with this IG, when you ventilate, you are going to let go some of the hydrocarbons. Now that is going to be a problem. So now that is what is called volatile organic compound or hydrocarbons, which is, if it is let out into the atmosphere, which is going to have an issue of global warming. So this particular regulation expects every ship to have a vapor return line. And every tanker as of now required to have what we call VEX manual, vapor emission control system. I think tanker people, you are well aware of this. And as of now, every port where you do loading, close loading, the loading master is well consulted in when you sign ship shore safety checklist. And wherever possible, if you can give it back to the shore through the vapor return line, at the cargo manifold, at that point you have one return line also. Of course, we have a color code also, yellow, red color. So the vapor is returned to the shore. That is what is the basic concept of your volatile organic compounds. That's your regulation number 15. So apart from that, shipboard incineration, yes. Your incineration, whether it is batch loaded or continuous feed, the regulation has come from 2005 onwards. They have brought out some specifications of individual incinerators. They say that your combustion temperature should be more than 850 degrees centigrade, or if it is batch loading, then the rate of rising temperature should be within 5 minutes, about 600 degrees centigrade rise should occur in 5 minutes. So that basically the concept is the combustion should be complete with enough oxygen around, and also enough temperature, so that a higher temperature, so that no smoldering takes place. Now that is the concept of your incineration. Of course, reception facilities, yes, that is one. And then fuel oil availability and quality. Now that, what Annex 6 says, that the fuel oil that we use on board, the fuel oil has to be in line with the regulations, and then it shouldn't cause any issue to human health or engine performance or environmental issues. So they have come out under Regulation 18, BDN, Bunker Delivery Note, which all of you are very familiar, and the quality of fuel oil, and of course, most of the ship, almost all the ships, I should say, we follow the international, ISO 8217 standards. As of now, 2017 standards, that's the fuel specifications what we follow. So that's what basically the fuel oil. Of course, there it goes little more deep, like how to take samples, fuel samples, onboard fuel samples. When you are taking bunkers and analyzing the samples, how many samples you should take, what should be the size of the standard sample bottle, and how many you need to retain, one for sending it for analysis, and all those things go in fuel oil availability and quality regulation. Okay. Now, going a little more in your NOx regulation, you are now looking at 2 slides here. On one slide, you see air emission controls. Now, in air emission control, you see 3 different categories: Tier 1, Tier 2, and Tier 3. Okay, Tier 1 is a little older one, as you can see there, from 1st January 2000 to 1st January 2011. That means any vessel put in service or coming after 1st January 2011, as you can see here, it is actually Tier... so here if you see Tier 2, so Tier 2 engine is what after 1st January 2011. And Tier 3 specifications, as you can see, in Tier 1 it is 17, and Tier 2 from 14.4 to 7.7. Now the same thing what is written in this slide is put in the form of a graph. That's what you see here. Now suppose if you see in this graph, this on your x-axis you see the rated RPM, and in your y-axis you see the NOx emission in terms of grams per kilowatt hour. Now if you see the black line here, now the black curve you can call it, now that happens to be your Tier 1. And then the orange color what you see here, that happens to be Tier 2. That means as of today, all ships delivered after 1st January 2011 should comply with Tier 2. And if you see right down here, this is your Tier 3. That means ships delivered after January 2016, when the ships go to emission control area, mind you, only when the ship goes to emission control area, that is NOx emission control area, then you need to follow this. But gentlemen, I would like to ask you one question. But as far as sulfur is concerned, your Marpol Annex 6 gives a very clear indication. It just says, yes, you have to have 0.5% or you have to have 0.1% in emission control area. But whereas if you see your NOx regulation under Regulation 3, it doesn't specifically give a particular value for the diesel engine. It just gives a range. Now, can you tell me why the range is given? Like, for example, if slow speed engine is less than 130 RPM, probably your main engine, I'm talking about your slow speed diesel engines, that's your 2-stroke engine, your main engine. There it talks about less than 130, because please mind you, the regulations apply to only for diesel engines above 130 kilowatts. And also it doesn't apply to your emergency engines. For your lifeboat engine, it doesn't apply. Your emergency fire pump, if you have a diesel engine, it doesn't apply. Emergency generator engine, it doesn't apply. It applies only to engines above 130 kilowatts. But the question is, now if you see less than 130 RPM, 14.4 grams. But more than 2000 RPM, 7.7. That's what you see in the graph. Can you tell me, my young friends here, what is the reason why a range is given? Hello? Some of the students listening to my lecture, can you tell me the reason why there is a range given? What is the reason? Yeah, please come. Hello? Nobody's answering?
Yes, sir. The question is about the range between 130 to 2000.
Now, yeah, correct. Why there is a range given? Suppose if you see above 2000, 7.7 grams, and less than 130 is 14.4. Now, if you see in this graph it is given. Suppose if your engine is an auxiliary engine, Say, let us say your auxiliary engine is about 800 RPM. Now see, from 800, if you go right on top, now what is the value you are supposed to maintain? Somewhere around 9 point some or whatever it is. Now my question is, why they have given a range?
Because it is about residence time. It is about residence time.
Yes. The reason for it is your residence time. Suppose if you take a slow speed engine, now the slow speed engine at 90 RPM, in 1 minute, how many revolutions? 90 revolutions. That means for every revolution, you have a time of 1/90. Whereas if you have your auxiliary engine, what is the RPM of your auxiliary engine? Let's say 800 RPM. That means in 1 minute, 800 times. That means 1/800. You see that this is what is called residence time. So the formation of NOx, if you look at this slide, now what I am trying to discuss now is this particular point, residence time. You see this. So the formation of NOx is like this. So how can you control NOx? If you want to come down, you are coming down from tier 1 to tier 2 is not an issue. But going down from tier 2 to tier 3, so engine makers have to have something, done on, onboard engineers, we cannot do anything because the engine manufacturer has to bring in something. So what they have brought from tier 2 to tier 3 by primary methods alone, just by engine tuning alone, nothing can be done. You need to have an additional attachment, something like what we call usually selective catalytic reduction or what we call exhaust gas recirculation. This either any one of this has to be incorporated in the engine. Then only you will be able to. That means your emission control area for NOx, which happens to be only North American waters. So whenever you come over to emission control area, NOx emission control area, the engine has the capability of bringing down the NOx value from 14.4 grams. I am now looking at a main engine about, say, around 90 RPM. From 14.4 grams per kilowatt hour right down to 3.4 grams per kilowatt hour. How are you going to do that? That means as long as your vessel is in the emission control area, you will be sending your exhaust gases not directly to the atmosphere, directly to ACR, and then whatever coming out from ACR after NOx reduction will be sent into the atmosphere. Now, I hope you understand this slide. And if you have any questions, you can ask me. Very easy for you to understand. Okay, now let me move on further. Okay, now let's move on. Now, what I have put now, this is what we call, you all know that every engine must have engine international, like your IAPP, EIAPP is a requirement for every engine. And these are all called NOx influencing parameters. So that means anything, that means you need to maintain a NOx technical code, of course, a technical file, and then any maintenance you do, or, you see the timing, injection timing. Now the injection timing is about, let's say, 8 degrees before TDC. Suppose if it is made 9 degrees or if it is made 8 degrees, it's going to have an effect on NOx. And of course, injection system components, that means anything that, these are all the components or the components, will have IMO number. And these, initially when the engine is tested, there is a certificate given to the engine International Air Pollution Prevention Certificate. And down the line, after 1 year, 2 years, or 5 years, how do we say that the vessel is still in continuous compliance of the required regulation? How do we do that? That is done by as per your NOx technical code. So at any point of time, any component you change, because components will wear down. Let's say after 3,000 hours, you'll have to change some component. Maybe some piston ring is broken during decarb, and then you have changed the piston ring, or anything that you do, you need to make sure that the IMO number and the spare parts procurement has to be from the engine manufacturer. And then you need to use exactly the same component with the same IMO number. And of course, if you just see here, some of the places it is given, apart from turbocharger and all that, there are some timings, like, as I have said, timing, or even the shims, you see the shim here, compression ratio. If you just suppose if you alter the shim thickness, what will happen? Your clearance volume will change. Then your compression ratio, it will have an effect. So this I just wanted to mention about this. Now, these are all the emission control areas, gentlemen. Now, I don't, all of you know this. This is what basically earlier we used to call it SOx emission control area, starting from 5 degrees west, entering English Channel, North Sea, Baltic Sea, and all that. This used to be SOx emission control area. And this used to be North American waters on either side. It used to be both NOx as well as SOx emission control area. But if you, as of today, if you just look at which is the NOx emission control area, only this North American waters. But then from 1st January 2021, that means coming 1st January, you will find there will not be going to be any more confusion. these SOx emission control areas, SECA areas are also going to become NOx emission control areas. I hope you are aware of this. From 1st January 2021, if you refer to Annex, Marpol Annex 6, it very clearly tells you that these areas are also going to be NOx emission control areas. That means there is no specific difference between NOx and SOx emission control area. So it's going to be a very single emission control areas for both NOx and SOx. That's how it's going to be. Then it's going to be a problem for the ship owners. Like, for example, ships delivered after 2021, when you enter, because many ships keep coming into this area. Any vessel entering here has to comply with Tier 3 NOx emission controls. What is it? For main engine, it is 3.4, as long as the RPM is less than 130 RPM. So this that means, in future, how I'm looking at it, almost all the ships will have your selective catalytic reduction or exhaust gas recirculation. So that when you go into the emission control areas, you come down to Tier 3 specification limits. And then when you come into global areas, you come to Tier 2. That's how it's going to be. Otherwise, the emission, that's the reason I'm not, right on top, you can see in this slide, I've written just emission control areas. This applies both for SOx as well as NOx. I hope it's clear. Okay, now let's move on to the next regulation. The next regulation is about sulfur oxides. So sulfur oxides, it's very simple. The regulation Annex 6 very clearly, even 10 years back, regulation has very clearly told us from 1st January 2020, switch over to 0.5% sulfur. Not now. I am talking about 10 years, 2008, 2009. That time itself, it has been told. But then what is the option? Now, either you switch over to 0.5%, that means from 3.5 right down to 0.5. It has already taken place, so I don't want to waste time talking about it, because now we are almost, first week of April. So all ships, they have switched over. Now, what are the, in case if you don't switch over, what are the options available? Suppose compliant, see here I have put compliant combustible media, compliant fuel. That means 0.5% sulfur when you are using. So it's very easy. You use this, either 0.5% MGO, MDO, or the next one is 0.5% heavy fuel oil blends. Or in case if you decide to stick with 3.5, then what you need to have with scrubber. Now this is one option. I'll just highlight on this issue a little more. And what is the next option? So now these are all the 4 options available for the ship owner. But then the last one, where you see LNG, LPG option, that cannot be that easily, as a retrofit, it is not practically possible. So it is possible for new ships, yes, but not for existing ships. So existing ships, either these two, very easy for us to do. And each one, if you go a little more in deep, now let's look at MDO, MGO scenario. Now here, what you can do? These are the advantages. Widely used and low capex. Gentlemen, can you keep your mic muted, please? Hello. I request moderator to mute all the mics except mine, please. So here, if you see the advantages, low capex, your capital expenditure is comparatively less modification. Hardly any modification. Straight away you are switching over, but then is it practically feasible? What are the disadvantages? Look at the price gap. Heavy fuel oil and using MGO, MDO, that means you do transatlantic ocean sailings or trans-Pacific sailings. How many days? Probably, if a ship owner decides on this, then he has to look at the price gap. That's what is highlighted here. Of course, low viscosity, because lubricity is an issue, because when you, this sulfur present in the fuel, what we understand, it gives some sort of a lubricity characteristic. So when you keep reducing the sulfur, say from 3.5 to 0.5 even, or from 0.5 even further down, of course in MDO, MGO, then the lubricity factor is absent. So if lubricity is absent, then what will happen? That means look at the wear down, what happens in the fuel pump between the plunger barrel and of course your, wherever lubrication is required, it's going to be a problem. So, okay, some additives can be added. So that is an issue. Of course, availability of so much quantum. If every ship owner decides to go on MDO, MGO, how much fuel you need? So those are the plus and minus points. Now let us look at this. 0.5% HFO hybrid. So what are the advantages? One thing is the price factor. No modification needed, yes. It behaves like a heavy fuel oil, yes. But if you are looking at the other side, disadvantages, compatibility, stability issues, okay, that means no co-mingling is not recommended. Quality contamination issues probably will settle down later. Limited availability lead to price volatility. But immediately when we change over, now what I understand from my friends who are sitting in the office as superintendent, they tell me things are settling down now. So maybe things will improve. So these are all the HFO issues. Otherwise, the third option is what? You continue with 3.5%. Of course, with the scrubber. The scrubber is very similar to, you need to just visualize about what we have on board an oil tanker in your IG plant. In your IG plant, you have a scrubber. What does the scrubber does? The scrubber scrub means what? Clean and cools. So likewise, you need to have a scrubber. And where do you locate the scrubber? Now see, the scrubber is somewhere here where exhaust gases are getting emitted. It's your funnel. So the scrubbers are open loop, closed loop, and hybrid, as you can see, all the three types. But then open loop means what? You are using seawater. Now the seawater will get acidified because as seawater becomes acidic, and then you can't afford to throw it out into the probably in open ocean, yes. But when you come into the coastal water area, there are many flag states. Many coastal states have already warned the ship owners not to throw out this effluent coming out from the scrubber into their waters because the water is acidic. So your open loop, that is the biggest disadvantage. Okay, maybe in open ocean you may be able to do that. Of course, closed loop, yes. And of course, hybrid means what? That means in open ocean you follow open loop, and when you enter the coastal waters, then you switch over to closed loop. And this is a very typical closed loop system. You can just have a look. And your seawater here is used only for cooling the freshwater. Now you have a freshwater tank, what we call process tank. A pump takes the freshwater through the heat exchanger, where cooling is done. Then effectively it goes to the scrubber in the funnel, and then coming in direct contact with the exhaust gases, pulling out all the acids. So the acidic freshwater comes here. See the pH value. There is a control of pH value is measured, and then it comes back to the process tank. Now this pH value, as a feedback is given to the unit here, caustic soda unit. Now the caustic soda unit, based on the pH value, it gives an injection here. What for? To neutralize the effects of acid. So this is a closed system. But eventually what will happen? Now acidity has been neutralized, but the water will become more of carbon soot will be there, and contaminants will be there, particulate matter will be there. So then what needs to be done? So from the process tank, you have a treatment plant, water treatment plant, where the sludge is dumped into the sludge tank. Okay, now this is, you can have a closed loop. I just to put this slide so that you have an idea how things are. Now, if you are looking at the advantages and the disadvantages of this, see what are the benefits? Lower cost for purchasing of heavy fuel oil, single grade fuel, because as you know, by March of this year, we cannot have any 3.5% sulfur fuel on board if you opt for compliant fuel. That is also there. So these are the benefits and these are the challenges, and which already I have mentioned it. And otherwise, switch over to LNG, because LNG switch over, that means, as I have said, as a retrofit, it's not possible. But then new building, of course, there are many ships which are switching over. I'm talking about bulk carriers or oil tankers or many container ships. Apart from LNG ships, we are switching over for LNG bunkering and LNG bunker tank, and then they have installed what we call dual fuel diesel engines. And a couple of ships are already running last more than a year now. And maybe any of my future classes, I will discuss more on this. Otherwise, LNG is the option, but then not as a retrofit to the existing ship. This one I just wanted to touch. Now, FONAR, suppose in case if you have this issue, fuel oil non-availability reporting to start with. This may be, I think, by 1st January 2020, this regulation has come. Initially, if at all you have any issue, then the FONAR is reporting. In case non-availability reporting, you are supposed to do it to the flag state and all that. These are all the contents of the phonar. So I thought I'll just put a slide on that just for you to just have a look at it. So you need to give all the details, no? And look at the second point: ship's voyage plan in place at the time of, and then where it received notice of the proposed voyage, what actions taken to attempt. So these are all the points, the ship has to give, and the flag state you need to inform them that the availability of compliant fuel was mainly because of this. So this is what we call phonar. Okay. Now, so far, these are all the regulations which were already there. But the new one, what they have brought out in Annex 6 is these issues. You see, Energy Efficiency Design Index and Ship Energy Efficiency Management Plan. And you see, regulation number 22A, it has become mandatory now. Collection and reporting of ship fuel oil consumption data, which the ships on an annual basis, the ship owner collected from the ships above 5,000 gross tonnage and pass it on to the flag state. And eventually the flag state has to pass it on to the IMO. And then this is a verification of compliance. I just mentioned it earlier when I started the session. This verification of compliance is nothing but it is there in SOLAS and Marpol. So far, the IMO, which has been making regulations for the flag states, now it is going to do an audit of the flag states. Now that's what it is. As you can see here, the compliance of any of the conventional regulations, IMO directly is going to form audit committees, auditors picked up from the flag states. So the audit committees will carry out audits of all the flag states at as per the plan. As you can see, Secretary General of IMO is responsible for doing this audit scheme. Now that is what it is. So it is more of a auditing of the flag states. That is what that one. Okay, now focusing more on these issues on global warming. Now look at this. Now this regulation came in 2013, a bit. So what does it say? That means 1st July 2015, if your vessel is delivered, that your vessel has to have a energy efficiency design index. That means if the vessel is earlier, before this date, it is not required. Only vessels delivered. So new ships above 400 gross tonnage. And there are two things here. One is attained EEDA and the other one is required EEDA. And also we talk about ship energy efficiency management plan. So now, once the compliance of this chapter 4 of Marpol Annex 6, where we talk about energy efficiency, then there is going to be a certificate. As you can see here, International Energy Efficiency Certificate will be issued. Now, this International Energy Efficiency Certificate becomes a mandatory requirement to get your overall IAPP. So now, let us understand what is EEDA. Your EEDA is also known as Attained Design Carbon Dioxide Index. So this you can say environmental cost divided by benefit for society. And the formula, whatever is given in Annex 6, it has been condensed, in a very simplified form here for your understanding. So you can say these are all conversion factors are given. Now SFC, basically this is what is it? Specific fuel consumption. That means now you look at a voyage starting from A to B. So during the voyage, how many tons of fuel oil consumed? So that has to be taken on one side. And the quantum of cargo transported from A to B. How many, if it is a passenger ship, how many people? Or if it is containers, how many TEUs? Or if it is any other cargo, how many? Let us say VLCC is transporting about 300,000 metric tons of cargo from Persian Gulf to Australia. What is the distance? Say about 4,000 nautical miles. So distance is 4,000 nautical miles. And cargo carried is about, say, 300,000. Then how much fuel oil consumed for this voyage? So you need to go from that angle. So use it in the formula, or eventually what we are, the bottom line here is, for transporting 1 metric ton of cargo over a distance of 1 nautical mile, how many grams of CO2 we have emitted? The gram CO2 emitted comes from the fuel oil consumption. See, that's what is given here. Gram CO2 divided by capacity, cargo quantum carried multiplied by nautical mile. Now, this is how your EEDA has to be understood. But the attained EEDA is the one what we calculate on board. I think your chief engineer should be getting fuel figures and the formula in the ship's computers, you work it out and then you send it to your company. And this is what is basically your attained by the ship. But what is required? Now, if you see the next one, look at the graph. I made it a little bigger here. Now, this is your required EEDA. every type of ship, this type of graph has been drawn. This is what we call EEDA reference line. And if you look at your MEPC 63 more in detail, in 2012 itself, they have given calculation of reference line. Now, how do you do it for a bulk carrier? How do you do it for a container ship? How do you do it for a tanker? For every type of ship, this type of reference line is made. So, if you see from the reference line, let us say a bulk carrier built. So, let us say your bulk carrier capacity is about 80,000 tons. Somewhere here you have built. Then what do? Go in this graph. Now, this graph is set for bulk carriers. As you can see, reference line for bulk carriers more than 4,000 gross tons. So, what do? From 80,000 tons, you go all the way here and then come back here. Now, then what is going to be the EEDA value? It's going to be some 4.2, 4.3, whatever it is. Now, that happens to be the EEDA required. That means, of course, attained, you need to compare it. Now, you need to calculate using the formula given in your Annex 6, and then your attained EEDA has to be less than the required EEDA. Now, that is how your Annex is going on. So, basically, what is EEDA? Again, in a different form. Number of grams of CO2 emission per ton nautical mile estimated by the ship specification for the new ship. As I said, ships delivered after 2015. Of course, SEAMP, you are very comfortable. I think SEAMP is required for all types of ships, whether it is existing ship or new ships, whereas EEDA is only for ships after 2015. So vessel performance is monitored. Your SEAMP introduces a mechanism for companies to collect data and monitor energy efficiency. All that is done. So shipping companies, you are all doing it. There is nothing new here. So unless otherwise you have. But energy efficiency operating indexes, basically, this can be done for all types of ships, existing as well as new ships. And this is somewhat like your attained EEDA. That means, for example, nowadays many ship owners, they resort to underwater hull cleaning more frequently, say every 6 months. Whereas earlier, ship owners will wait when the ship goes to dry dock. That's about 1.5 years. But now they do it more frequently. What for? We have seen the performance of the engine with reference to fuel consumption before hull cleaning and after hull cleaning. So when you do that, then there is going to be a change in the value of your EEOI. So the basic concept is, if you want to optimize your CO2 emission, then that means you need to minimize fuel consumption. So that way it helps you. So now here, IMO has got a plan. That means all types of ships, by 2025 onwards, you need to come to phase 3. Now what? Phase 1 is finished now, 31st December 2000. Whatever I'm showing you, you will see it in Marpol Annex 6. Now this tabular column, what does it say? Now we are in phase 2, starting from 1st January 2020. That means what must have happened, 10% of CO2 emission reduction for bulk carriers or gas carriers, or for that matter, all types of ships are covered. So you see on the left extreme here, you see tanker, container, general cargo, refrigerated cargo, or LNG. So by December 2019, you see uniformly 10% of CO2 emission reduction compared to what it was in 2012-13. That is how IMO is looking at. But how will you quantify? So that is why now IMO has brought out this regulation. Any ship above 5,000 gross tonnage, you need to have fuel oil. You need to collect and ship fuel consumption data has to be passed on by the ship owner to the flag state, then from the flag state, eventually to the IMO. So now this table just gives you an idea. That means end of this 5-year period, you will find every phase is 5 years. Now the phase 2 starts from 1st January 2020, ends with 25. So another 10%. Whereas 1st January 2015, phase 3, it's almost 30%. So this is what is the IMO's plan. So what ships can do? Regulations aside, regulations, yes, Marpol Annex 6 gives you many guidelines. What are the other things ship owners are resorting to doing? Weather routing, yes, all of you understand. And energy consumers on board. Now look at any of the energy consumers are all the motors on board. Whether it is a hydraulic motor or
Mr. Sekhar, sir, this
yes.
is moderator. Sorry for the interruption. 8 minutes left, sir. And
some
questions are raised by candidates.
Yeah, let me finish this, then I'll take questions.
Okay, sir. Thank you.
Okay. So, gentlemen, you can see in this slide, efficient operation, speed optimizing and trim. I think we do economical speed, or many ships or we are doing it. See, when you reduce the speed, what happens? Your consumption comes down. When consumption comes down, your CO2 emission comes down. And of course, trim, ships like container ships are going down by head now. They say half meter trim, down by head, or 1 meter. And of course, more efficient technology, fuel shift. I think I mentioned already about your LNG ships. When you switch over to natural gas, what happens? Your CO2 emission reduction comes down by about, say, 30%. Because you must understand, LNG is also, what is LNG? CH4. That's also a hydrocarbon. So basically, CO2 emission reduction means what we need to look at. The focus should be reduce power demand, ship and propulsion design, and improve efficiency. One is propulsion optimization. Many things we are looked at. Propeller designs, number of blades, ducted propeller, contra-rotating propeller. There are many propeller designs are looked at. Of course, the profile of your bulbous bow is also looked at. And of course, engine technology, electronic engines reduce, where your SFOC goes to the minimum. Waste energy recovery. In some of the ships, you have, even at the funnel, you have a, gas turbine, connected to an alternator. That sort of waste energy recovery, this type of things. Of course, alternate fuel. So, efficiency areas where we can look at to bring down your CO2 emission or fuel oil consumption. It's all that. As you can see, design, propulsion, machinery, operation, and maintenance. Maintenance part of it, propeller polishing and your hull cleaning, too frequently can be done. And I think we are already doing it. So these are all the issues. And on the whole, if you just see this in a nutshell, if you just look at the slide, see what are all the things, see there, your x-axis, this is your x-axis, and y-axis is what? Cost per ton carbon dioxide averted. That means, suppose if you voyage execution, optimization, like steam plant, speed reduction. Suppose if you take speed reduction, what happens? Speed reduction gives you so much of fuel. That means it's going to be plus point. Now this is 0, this is minus $20 per ton. That means these are all the plus points up to this. And then once you come here, gas fueled electronic engine, the cost is slightly up. Then your lighting. So whatever this side, what you see is going to cost, installation cost is going to be there. But then eventually it's going to be CO2 emission reduction, it is optimized. Like for example, you see cold ironing here. What is cold ironing? Cold ironing is what? Taking power from the shore. If you do cold ironing, taking power from the shore, then what we need to do? We need to pay to the coastal state wherever your vessel is. So this will give up, okay, solar panel, not shown. So you will find some of the ships, they have solar panel, they have wind generators. These are all the fuel savings and waste heat recovery. So there are so many issues, so many, in a nutshell, if you just look at the slide, there are many things suggested. So eventually, the ship owners are also looking at how to reduce the fuel and how to, how to come within the IMO's target period, so that you will find beyond 2025, there is going to be a reduction of almost 30% of CO2 emission reduction from the ships. And one more thing, if you just look at the CO2, if you look at the second paragraph, second point here, a carbon trading mechanism will be established in order to apply to the shipping, to limit their carbon trading, to limit their carbon emission. Now, let us understand what is this carbon trading business. Now, this is already in the pipeline, and as of now, it has not come. And this is basically called the cap and trading mechanism. Cap means what? Set a limit on the amount of pollutant that needs to be emitted. Then trade. Suppose, for example, if you see right at the bottom here, one carbon credit is what? 1 ton of CO2. Like, for example, you need to make one power unit. So, for making 1 megawatt power, suppose if you use a windmill and make 1 megawatt power, how much CO2 you are emitting? Nil. Or from solar panel, if you make 1 megawatt of power, you are not emitting any CO2. But if you make 1 megawatt of power by using fuel oil or diesel oil, you would have definitely emitted some CO2. That means a company makes 1 megawatt of power with solar panel. Now that should get a credit, because that needs to be given some sort of an incentive by a company which makes 1 megawatt of power using fuel oil and emitting CO2. Now this is what is called a trading. So the company which makes 1 megawatt of power without emitting CO2 should get 1 carbon credit from a company which is making 1 megawatt of power and generating CO2. Now that is the concept. Now anyhow, this is in the pipeline. We will see when it comes. Otherwise, for making this presentation, gentlemen, these are all whatsoever website I visited. International Chamber of Shipping, I have taken some slides, and of course IMO website and IHS Fair Play and European Union website. These are all the websites I have visited. But anyhow, now I will take the questions. Moderator, you can go ahead and whoever is asking question can ask me.
Yeah, Mr. Sekhar, sir, the one of the question raised by Mr. Karan Mahija. What is the power requirement for tier 1, 2, 3?
He's talking about NOx emission levels. Who is asking this question? Can you ask me this question now?
Mr. Karan.
Sir, Karan here, sir. Good morning, sir.
Yeah, good morning, Karan. Tell me, you want to know the NOx emission limits of tier 1, tier 2?
Yes, sir. Sir. Yes, sir. As you already mentioned, I got the answer. Meanwhile, your lecture, it was 130 you mentioned. That was actually I was looking for.
Okay. So this is applicable to all engines above 130 kilowatts, but it is not applicable to emergency engines, because emergency engines, as you are aware, when it is going to be a lifeboat engine, there it is more important is safety, not pollution prevention. Okay?
Yes, sir. Yes, sir. Thank you, sir.
Okay. Any other question, gentlemen?
One more question raised by Mr. Dharmaveer and Nitin. Residence time explanation.
Residence time, let me explain it like this. Gentlemen, suppose you look at your main engine. Main engine is running at 90 RPM. Okay, that means in 1 minute, it makes 90 revolutions. That means the time for combustion is how much it is. You can take it as 1 by 90, isn't it? Because 90 revolutions in 1 minute it completes. That means 1 by 90 is the time. Now within that time, your fuel is injected in your combustion chamber, and the oxygen and nitrogen, because for formation of NOx, you need nitrogen, which is there in the air that is supplied, scavenger that is supplied for engine combustion. You have oxygen and nitrogen. But for the nitrogen to react with oxygen at that temperature above 1300 degrees centigrade, you need some time, So by the time nitrogen starts reacting with oxygen, in slow speed engine 90 RPM, you have more time. So nitrogen will comfortably react with oxygen and it will keep generating nitrogen oxide. Whereas if you look at your auxiliary engine RPM will be about, 750 RPM or 800 RPM, let us say. That means in 1 minute, 800 times. That means what will happen eventually for combustion? It is more or less, 1 by 800, something like that. The time is so short. By the time nitrogen start reacting with oxygen and make this NO or NO2, by the time your exhaust valve opens, and then, because there is no time for the nitrogen to form NOx, by the time it gets exhausted through the exhaust manifold. So that is what you must understand. So in slow speed engine, the time is 1 by 90. You tell me 1 by 90 or 1 by 800, where the time is more? Hello?
1 by 90, sir.
1 by 90 means you have more time. So more time for nitrogen to react with oxygen to make nitric oxide or nitrogen dioxide. Whereas in 1 by 800, what happened? By the time, temperature is all right, 1300, all right. But nitrogen is about to react with oxygen, but by the time exhaust valve opens and everything goes up. Do you understand that? So that is why they have given a range depending upon the RPM. As you can see, if the engine RPM is more than 2000 RPM, they say that it is going to be very less. Like for example, if you take tier 2 engine, so 14.4 grams on one side, that is for slow speed engine. Or on the other side, what do they say? 7.7 grams. Where is 14.4? Where is 7.7? So 14.4 is for slow speed engine, less than 130 RPM. Whereas if you see 7.7 is for engines more than 2000 RPM. So same thing follows for tier 1 or tier 2. In tier 3 also you will see the same thing. You will see 3.4 and on the other side 2.2. So always, slow speed engines, the possibility of NOx formation is more. So they have given, it is something like exactly what is happening when you are doing, running race in a ground, So suppose if it is a relay race, that means that there are inner circle and outer circle. Inner circle, his circle is less, compared to the outer circle. So it is something like that. Do you understand? Hello?
He haven't given the feedback in chat, sir. Thank you.
Okay.
Another question raised by Mr. Jit. Does Tier 2 vessel can go to ECA area? So under what circumstance it is satisfying the rules and regulation?
Tier 2 vessel going in emission control area.
Yeah.
Gentlemen, listen. Now, see, your emission control area, ECA means emission control area. As I have said now, emission control areas as of today, if you see, it is only North American waters for NOx. Now, let's not confuse with SOx and NOx as of today. As of now, SOx emission control areas are European areas, English Channel, North Sea, Baltic Sea. And North American waters is only for NOx emission control area. But from next year, IMO has already, it has come out and it's going to enter into force from 1st January 2021. What is going to happen? All these emission control areas will become one. That means